Three is another one of the ones with coordinate geometry where I'm going to jot down some notes and then go over to a coordinate plane and then just do them all at once. So essentially what happens is we're given three tasks that we're supposed to graph. We're supposed to use coordinate geometry to figure out if they have special shapes, special things about them, so we can name them a kite or a square or a rectangle or whatever. And then we're also supposed to calculate the perimeter. So that's kind of annoying because I'm kind of sick of doing that, but whatever. So anyways, like I said, I've jotted these notes down. I'm going to go over to the coordinate plane now and sort of get to work on these. So I think the regular coordinate plane will be fine here. So the first one, we had a y-intercept of 3, and it was down 3 over 2. And we needed to make a line that goes through here. So the line will look something like this. I mean, obviously it would extend, but it's kind of not really material for what we're doing right now. Now I have one at -3. Oh wait, -1, 2, 3. And the slope is going to be up 3 and over 2. So that'll hit right there. And again, that would extend beyond that. I guess I'll just kind of make it extend beyond it, but I want it to be able to hit those points just so we're on the same page there. All right, the next one had a y-intercept of 9, and it was going down 3, and over 2. So down 3 and over 2, and down 3 and over 2. So we're going to get something that looks like this. So we can see we definitely need to extend this one. And then finally we have one with the y-intercept of 3, and it's up 3 over 2. So it's going to look something like that. So what shape do we get? It definitely looks like a rhombus, but now we need to verify that it is a rhombus. So you can see the length here is a 3 by 2. This length here is a 2 by 3. This length is a 3 by 2, and this length is a 3 by 2. So you can see the slope here, down 3 over 2, down 3 over 2. These are parallel. Up 3 over 2, up 3 over 2. Those are parallel. You can see up 3 over 2 and down 3 over 2. Those are not negative reciprocals, so we don't have corners here. They look like they want to be negative reciprocals, but they're not. Also, the square roots, obviously it's going to be 9. It's going to be 3 squared plus 4 squared equal, 3 squared plus 2 squared equals this for all of these. So I can figure out the side length on all of these at once. So again, it's going to be the square root of 3 squared, which is 9, plus 2 squared, which is 4. So I get the side length of 3.6 for all of these. They all have a side length of 3.6. So that definitely appears to be a rhombus. And the perimeter is just going to be 3.6 times 4. So we'll times 4. And our perimeter is going to be about 14.42. So that's the shape we get for here. All right. Not bad. Off to a decent start. Actually, I don't need to close that. So let's go ahead and just reopen a new coordinate plane. So we'll discard that. And we will plot these points. 0, 2 was A. 1, 0 was B. C was at 7, 3. And D is at 4, 4. So what shape is this? So if we go here, it looks like the shape is going to look something like this. So I'd say best case scenario, we have a trapezoid here. So that would be best case scenario. So these would have to be parallel slopes. So up 2 over 1, 2, 3, 4. So up 2 over 4, that is obviously a slope of a half. And this would have to be a half as well. Up 1, 2, 3, and over 1, 2, 3, 4, 5, 6. So there you go. 3 over 6 is the slope of 1/2. So we do have a trapezoid. Nice. All right. There isn't going to be anything else special about this. So actually, it's probably a right trapezoid, right? So here, our slope is down 2 over 1. And here our slope, we already know, is a half, so a negative reciprocal is a half. So yeah, we have negative reciprocals here. Our slope here is negative 2 over 1. Our slope here is up 1 over 2, up 1 over 2. So we do have negative reciprocals, so it's a right trapezoid. Not only is it a trapezoid, but it's a right trapezoid. Last thing we need to do is calculate the perimeter. So again, 2 squared plus 1 squared, so it's the square root of 5 here. Square root of 5 is going to give us a length of 2.23 here. This one is going to be 2 squared plus 4 squared. So the square root of 2 squared is 4. 4 squared is 16, so it's the square root of 20. So we get 4.47. This one is going to be 1 by 1, 2, 3. So it's going to be the square root of 1 squared, which is 1, plus 3 squared, which is 9. So we get 3.16. I know I'm going through this fairly quickly. I hope you guys are fine with this. If not, just draw your own slope triangles and you should get the same numbers, unless I screwed something up. If I did, let me know. Here we have a 1, 2, 3 by 1, 2, 3, 4, 5, 6. So I'm going to take the square root of 6 squared, which is 36, plus 3 squared, which is 9. So it's the square root of 45, and I get 6.7. And my perimeter is going to be these added together. So 6.70 plus 2.23 plus 4.47. I hate when I don't get the decimal. At least I noticed it this time. Plus 3.16. And we will get a perimeter of 16.56 for this whole shape. And again, we're making these slope triangles. 3 squared plus 6 squared. 3 squared plus 6 squared equals 6.7 squared. That's how we're getting these distances. 1 squared plus 3 squared equals 3.16 squared, etc. All right, and then on to the final shape. So we'll go here. And the final shape, we had a point at, it appears to be 0, 5. Let me double check that before I get too far into this thing. I would hate to not have that right. So 0, 5 it is. So 0, 5, we're going to have a W. 2, 7, we're going to have an X. 5, 7, we're going to have a Y. And 5, 1, we're going to have a Z. So what shape is this? And I'm guessing this is a kite, maybe. But I don't know if it's exactly going to be a kite. It should be interesting to see if it's actually a kite. No question, we have ourselves a corner right there, right? That's obviously a 90-degree angle because we have an undefined slope, but the slope is 0. So that much is easy. This length is pretty easy. It's 1, 2, 3, 4, 5, 6. This length is pretty easy. It's 1, 2, 3. So not much effort for those, but is this length 3 and is this length 6? We'll see. It doesn't look like it. 2 squared plus 2 squared. So I'm going to get the square root of 2 squared is 4 plus 2 squared is 4. So the square root of 8 is 2.82. So it's close to 3, but it's not. And this one is going to be 1, 2, 3, 4. And 1, 2, 3, 4, 5. So it's going to be the square root of 4 squared, which is 16, plus 5 squared, which is 25. We're going to get 6.40. So again, not exactly. So it wants to be a kite, but it's just a quadrilateral with the right angle. Our perimeter is going to be adding these things up. 2.82 plus 3 plus 6, so we'll add 9, plus 6.4. And we're going to get 18.22. Just want to make sure I didn't miss anything on that one. So I'm going to go to the answers just to verify that actually quadrilateral has a right angle. It does not have a special name. And yeah, 18.2. So there you go. All right. I just want to make sure I didn't screw this up. Since I screwed up so much, hey, I'm done with chapter 7. It's been a long day.